Welcome to our biomimicry project. My name is Kayo, and I work together with Victor, Lorena, and Ming to implement biological systems into our sunflower mechanical design.
Project background and design. The emission of carbon dioxide is one of the main factors behind climate change. Therefore, modern society is currently seeking ways to reduce and reverse the levels of CO2 in the atmosphere. There is already a group of organisms capable of turning CO2 into oxygen, plants. For this project, we are originally wanted to use biomimicry engineering, which uses biological and natural elements as a base to create designs to create a mechanism that performs artificial photosynthesis. However, because of our limitations, we had to change our designs. This is an interclass project. Three engineering students and a biology student work together.
Here is our project planning process. So we had an initial sunflower iteration where we had to identify all our parts so we could separate our design, so we could set up our tasks for each other. So we have our solar panels here, and we knew that it had to be attached to something um, on the column. So then we have it fixtured onto a slab where it would be located in the park for it to be well fixtured to support its weight.
Photosynthesis includes light-dependent reactions and the carbon cycle. During the light-dependent reactions, the absorbed light energy is converted into ATP and NADPH, and then release oxygen into the air. During the carbon cycle, the ATP and NADPH and CO2 are used to produce G3P, then form glucose. We have done many searches about how to make the artificial photosynthesis happen. Unfortunately, after the discussions with the professor, the team came with the conclusion that the potential that we strived for was too complicated for the limited time we had. In order to continue our biomimicry project, we are engineering the sunflower to follow the sunlight to store as much as a light energy.
We picked the biomimicry project. Therefore, we had to ensure our design met the requirements for both classes, biology and engineering. Our mechanism here follows the sun, which mimics what a sunflower does. Each one of the engineering students was responsible for a sub-assembly, which had to implement biological systems.
For my sub-assembly, I decided to do the middle part, which was simple enough and it was just able to hold the top. And in the middle will be a panel, which will be to see what's going on the um, assembly and to run some wires through the middle that will also go to the bottom.
And so this part is actually going to have the motor too, which is going to be responsible for moving the assembly. So the motor is going to be connected to this part, and this is going to be the part that's going to make the movement possible. I was responsible for the top part. So we had the pedals. Originally, I made them like this. It was too heavy for the design. So I removed some of the material to ensure it was light enough for the base. So here we just have a pin and the disc floret, which is going to have the sensors, which are going to be used to detect the sunlight and thus make the flower move towards the sun as the sun sets in the horizon. And then we did have some challenges. So there was a lot of miscommunication and we struggled to participate. We also struggled with time management. And unfortunately, we were only notified that we would have to change our design three 3 weeks before the final project was due. And again, unfortunately, none of us was none of us had any mechanical engineering design background, so that was also a challenge. And then these are the references we use for this project. And so thank you so much for watching this presentation, and please feel free to leave any questions you guys have in the comment section below, and we're gonna try our best to answer them in the next week.
Beautiful.
Did it go through?